Hello everybody and welcome to this video tutorial series in electronics. And I know a lot of guys want to learn electronics, and electronics is quite hard. Not that you have to be really smart to do it, but there are a lot of components and a lot of design rules you need to keep an eye on. And basically one of those first things you really need to learn is what all your basic components do. And we're gonna take the resistor today to show you how simple a resistor can look, but how complex it could be when you actually use it. So what you can see over here is a 12 volt power supply, a resistor, and a diode or an LED, and a switch. If we run the simulation and we press on the switch, it goes on and off and on and off and on and off. Alrighty, that's something you understand. But why does this work the way it works? Well, that's basically kind of easy. Inherently, a LED or light emitting diode has no internal resistance because it's a diode. It's inherently low resistance. So if we would take a 12 volt power supply and we take a 4 volt LED and only a switch, and we do not use this resistor, like a resistor all says, it adds up in resistance on the line, and that has two major benefits. One, it limits the currents the circuit is running, and second of all, it eats away voltage. And that's why a resistor works the way it works. It sounds kind of complicating, but I'm gonna explain it to you. So if we start a simulation, and we can see if we switch it on and off, that's all fine and dandy. Here we can see a setup for the same system: a 12 volt power supply, a switch, a resistor, and eventually going into multimeter 1, that's this one, and we will measure the amps running through the resistor next to ground. So if we take 6 ohms and we switch it on, we've got 2 amps running and 20 microvolts on voltage. That's kind of strange, but we'll explain this one. You've got a 12 volt power supply and a 6 ohm resistance, so 12 divided by 6 is 2, so hence the 2 amps. If we switch this one off and take a 12 ohm resistance, it's 12 volts divided by 12 ohms is 1 amp, or 990.991 milliamp. It's basically the same. If we switch this one off and we take double the resistance this time, we switch it on, we've got 12 divided by 24 is 0.5, and 0.5 amps is 499.998 milliamps. But we still have these 5 microvolts on the end, and that's kind of strange. Here we have 10 millivolts, but why? Well, basically, if any power supply has any load, there will always be a voltage division. And I've made a small circuit to show you this. I took the liberty to make a 10 volt DC power supply. Excuse me. A 10 volt power supply and some resisting dividers or voltage dividers. I made 4 of them. One with 1 kilo ohm, 10 kilo ohm, 10 kilo ohm and 1 kilo ohm divided in half, 5 on 5 and 75% and 25%. As you can see over here, there's a voltage reference from here to here and from here to here. Because if we stop this simulation and we simulate an extra multimeter, you can see that on this point, let's take it over here, just for good measurement, 9, and I want to see a voltage over there. If we start the simulation, you will see there's 10 volts over here, from here to here. But because there are 2 resistors over here, you can divide it by 2. So that's 10% and 90%. And that's correct, because this divider creates from 10 volts 9 volts on this point. If we take the opposite, we're gonna go down. So hence multimeter 6 says 1 volt, and that's exactly 1/10 of 10 volts. If we take 5 kilo ohms, we can divide it in half, so half the 10 volts is 5 volts. If we take 25%, we'll get 2.5 volts. And that, ladies and gentlemen, is basically how a resistor works. You can build up way more complicated schematics and circuits with this setup alone. Just a switch, a resistor and an LED, or not even an LED. But this is basically what you need to go on to the next section, and that would be I think transistors. I think we're gonna do transistors. If you have any idea or thought on this video, please share it in the comments below. If you want a subject you want to see next time for capacitors, transistors, triacs, and so on and so on and so on, just put it in the comments. I will read it and I will see if I can make a video on it. Alright, well, for now I think we are done here, and I will hope to see you next time. Stay safe, guys.